everyone, and welcome to the first video on polynomials for the Year 11 Methods course. In this video you're going to see a number of notes. Now what I'll say is feel free to pause the video at any time to copy down the notes into your workbook, and also that if you have any questions about any of the information that's provided here, you can either contact myself or your regular classroom teacher. So we're looking at polynomials, and there's a little bit of language at the start of this topic. Now in order to get that, what I'm going to suggest is you have a quick read through your textbook just to familiarize yourself with the terms that are used there. What I've written on screen here though are a number of equations which are all examples of polynomials. So y equals 2x plus 3, y equals x squared minus 8x plus 17, and also y equals 2x cubed plus 7x minus 5. The thing that all three of these have in common is that firstly all the powers of x are positive or 0. So whenever we have a constant term like the 3 or the 17 or the negative 5, they can all be written with an x to the power of 0 term due to the index law that relates to that. The other thing is that all of the powers have to be whole numbers. Okay, so we can't have any fractional indices or anything like that. So the thing is, this is the way that we've always written equations. We've always written them as y equals something. Okay, but that is considered to be an informal way of writing it. So what I'm going to do now is introduce you to a new way of writing it. Okay, and this is going to be the way that you're going to see a lot of equations written moving forward from here. So typically, if I can get this to work, that seems to have fixed it. So typically, we would write equations, rather than writing them as y equals something, we'd write them as f of x equals something. Now you notice that I just called this here f of x, okay? So that's how we say it, and basically it just means y. They are considered to be the same thing, but f of x sort of well, what it actually means is a function of the variable x, okay? You're going to learn a little bit more later on about what functions actually are, but basically you can think of it as an equation that's formed using the letter x, okay? Now, what it does not mean though, and the thing that you have to be a little bit careful of is, when we see something in brackets next to something else, we automatically think that they're being multiplied. That is certainly not the case here, okay? So don't make that mistake. Now, I've just said here, we sometimes use different letters as well. So for example, we could use h of t to represent the height of a ball, which we could call h, t seconds after it's been thrown into the air. So the equation would be h equals something t. Also, in this particular exercise, we talk about polynomials a lot. And so rather than using f of x as the notation, the textbook will use p of x, okay? So p obviously standing for polynomial there. So it's just a polynomial written in terms of the variable x. So I've got a couple of quick examples here. Given p of x equals x cubed minus 5x, and q of x equals x cubed plus 2x squared minus 4x, evaluate p of 4. This is actually one of the nice things about this notation, is that we can easily solve substitution problems. So you can see here that what I've actually done when I compare this with this here is I've just replaced the x with 4. And so all I'm going to do is replace the x with 4 in this part of the equation as well. So that's going to be 4 cubed minus 5 times 4. And when I evaluate that, 4 cubed is 64. 5 times 4 is 20, leaving us an answer of 44. Same thing over here. So I've got q of negative 2, which means that I've replaced the x with negative 2, and so I'll replace it in the equation as well. That means that I've got negative 2 cubed, be a little bit careful of the negative sign there, plus 2 times negative 2 squared, minus 4 times negative 2. So always a risk with these kind of questions is just being careful with those negative signs. Negative 2 cubed should be negative 8, plus negative 2 squared is 4 times 2 is going to be 8. And then we've also got another plus 8. Gee, 8's everywhere. Now, these two cancel each other out, so we are actually just left with 8. And down here, I've got p of x multiplied by q of x. So when I write this, it's going to be p of x, which is x cubed minus 5x, multiplied by q of x, which is x cubed plus 2x squared minus 4x. And we can just expand those brackets out. This can also be done using your calculator, by the way, but I'll just use this method here. So we'll just multiply each of the terms. X cubed times x cubed, I'll give myself a little bit more room than that as well, is going to be x to the 6 because we just add the powers. X cubed times 2x squared is 2x to the 5. X cubed times negative 4x is minus 4x to the 4. Then I've got negative 5x times x cubed, which is negative 5x to the 4. I've got negative 5x times 2x squared, which is negative 10x cubed. And I've got negative 5x times negative 4, which makes plus 20x squared. And if I just collect the like terms there, well, there's nothing to group with the x to the 6, and nothing to group with the x to the 5 either. The x to the 4s, I'm going to be left with negative 9 of them. Nothing to group with the x cubed, and nothing to group with the x squared. So there we have it. There's one more thing for us to look at here, and that is the process of equating coefficients. So we've got some polynomial, x cubed minus 2x squared plus 3x minus 9, which can be written in this other weird form here. Find the values of b, c, and r. So what I'm going to do here is I'm actually going to expand this form right here. Okay, so x plus 1 multiplied by x squared plus bx plus c plus r equals, now if I expand this out using that same process of multiplying each term there, I've got x times x squared, which is x cubed. X times bx is bx squared. X times c is cx. Then I've got 1 times x squared, which is just x squared. I've got 1 times bx, which is just bx. I've got 1 times c, which is just c. And then I've also got a plus r on the end, which isn't in the bracket, so it didn't get multiplied with anything. You'll notice that there's a few terms here that have the same x. So like we've got bx squared and we've got an x squared here. And also we've got cx and bx. So I'm going to actually group those together. So I've got x cubed plus, now if I group those x squared terms, taking the x squared as a common factor, I would be left with b plus 1 x squared. And if I group those x terms, I would be left with plus c plus b x, so taking the x as a common factor out of them. And then I've also got a plus c plus r. Now the thing is, we know that that equation, we've just expanded it out, but we know that it's equal to this original equation up here. So I'm just going to say that x cubed minus 2x squared plus 3x minus 9 equals that. And we can see that they both have an x cubed term, so that's a good start at least. We can see that the coefficient of the x squared term here is negative 2. And we can see that over here the coefficient of the x squared term is b plus 1. So just because they are equal to each other, that means that negative 2 must equal b plus 1, which I can then solve for b. So if I take away 1 from both sides, that gives b equals negative 3. Alright, we're looking good so far. The next thing is to consider the coefficient of the x term. So I can see that we have a positive 3 as the coefficient of x. And over here, we have a coefficient of c plus b. So that means that 3 must equal c plus b. But the thing was that we already found out what b was, and we know that b is negative 3. So that means 3 equals c minus 3, which I can then solve for c by adding 3 to both sides and getting c equals 6. Now the last thing is to consider the constant term. Okay, we've got negative 9. And we've got two parts here that are making up the constant term. So my final thing is to say that negative 9 equals c plus r. And again, we found out what c was already. So negative 9 equals 6 plus r. Taking away 6 from both sides leaves r equals negative 15. And there we have our 3 answers. Anyway, that's about all for this video. So that's just covering most of the things in that very first exercise of the chapter. Have a bit of a go at it, see how you find it. And again, if you have any questions, don't hesitate to ask me or your regular classroom teacher. Thanks everyone, I'll see you next time.